Welcome to the lesson on complex numbers. First, we're going to try to find square root of -1 in your TI Nspire. Maybe you've tried this before, and if you do try it, you hit Control x squared, -1, and you get this error. It says non-real result. You must change the mode, okay? So hit the Home key, go to Settings, Document Settings, and change the real or complex mode to rectangular. When you do that and make default, that changes your scratchpad as well. Now if I go back to my document and I retype by cutting and pasting, press enter and press enter, now it tells me that square root of -1 is I. So it actually, the calculator does know how to do imaginary numbers if it's in the right form. Now, I know you're excited now about the calculator can now do these, but we're going to actually learn how to do these by hand, which is usually the way I want you to do them. So the number has been defined, so you need to memorize that. That is very important for you to know that I is equal to square root of -1. Now, if that's true, what's going to happen if you square I? So you get I squared. So you got the square root of -1 squared. Well, the square and the square root undoes each other, and they're kind of left with, well, not left with a star. That was good. You are kind of left with, let's get a pen out here. Okay. So you're actually left with -1. It's just kind of like it just falls off. It undoes each other. And so you need to memorize that I squared is equal to -1, which is really unique because we have I, which is imaginary, and -1, which is real. So if you get two i's multiplied together, you actually get a real number, -1. Let's use that to solve this problem. The very first time I'll do this, I'll kind of show a little extra work here, and then we'll kind of show you the shortcut. The first thing I want you to see is you can break up -4. We know that -4 is really -1 times 4. And we're also allowed to break that up within the radicals. So -1 times square root of 4. And so one of the things we just learned was that this is really equal to I, right? So this is really this is really I times square root of 4. I'm doing it slowly on purpose so you can see every step. And that's really going to be 2I. Because square root of 4 is 2. And kind of like 2x or something. You would never say x times 2. You wouldn't say I times 2. Self-respecting mathematician is going to say 2I. Okay. Now we've got square root of -25. This is the way I want you to think through this problem. And I think if you start doing this, you'll start getting these right. This is what you need to deal with first, this negative sign. So I'm going to take that out. When it comes out of the radical, it really looks a lot like an I, because that represents square root of -1. Right? We know square root of -1 is really I there. Those are the same things. And so I'm pulling that negative out. It becomes an I, and then just simplify the square root, we get 5I. And the last one here, you're going to pull the I out. Do that first. So I times square root of 5, and square root of 5 doesn't simplify, so I think we are done there. So a complex number is what we're talking about here. We are talking about complex numbers. Sometimes I'll almost use this term interchangeably, but they're just a little bit different. But they're usually, when we're talking about complex numbers, we're usually talking about imaginary numbers. So they have two parts to a complex number. It's very complex. They have two sides to the number. You have a real part and an imaginary part. And it goes in that order, usually A plus BI. And for example, even if you have the number 7, well, that's a real number, but I could write this as a complex number, one that has a real and imaginary part. I would just say 7 plus 0 times I. Now that's a complex number with only a real part to it. I mean, there's really no imaginary part to that. Adding, subtracting complex numbers is a lot like, 2x plus 3x. Like terms go together, that's equal to 5x, right? So similar idea here. You want to put like terms together. 2 plus 3 is 5. And then 5i and negative 2i. 5i minus 2i is plus 3i here. So you've got your complex answer. You added up the real parts, added up the imaginary parts, which is exactly what you do. Just be real careful on this one because this negative is being distributed. So the real part would be negative 1 minus negative 3, which is like plus 3. So 3 minus 1 is 2. And then the imaginary part would be 2i minus 4i, or negative 2i here. Multiplying complex numbers is pretty easy. We're just going to use the FOIL techniques. Go first, that would be 8, 2 times 4. Outside, that would be minus 10i. Inside would be plus 12i. And last would be minus 15i squared. You notice where the I squared came from. I times I is I squared. Well, one of the things, if you're paying attention earlier, is we know what I squared is. I squared is always negative 1. Right, so I can replace this with this. And that's going to help us out here. So let's simplify this a little bit. We've got, these go together nicely. We get 8 plus 2i minus 15 times negative 1. Well, you're subtracting a negative there, so you're really adding a positive. So we have 23 plus 2i. And that's our complex answer after we multiplied two complex numbers. I'm going to let you do the rest of those on your own here, but that one I'll let you do on your own, but I really want to go over this one with you. I think it's important because here's what you're going to be tempted to do. Please don't do this. Some students will go, oh, negative 3 times negative 12 is 36, so this is equal to the square root of 36. Not true. You've got to be really careful about that. Always take out the I first. So what does that mean? That means this little negative sign here, you want to pull that out. I times square root of 3. Pull this out first. So I times square root of 12. Okay. I times I is I squared. 3 times 12 is 36. So square root of 36. And what is I squared? Negative 1 times 6, which is negative 6. Find all the solutions of a quadratic. So you might be saying, why are we studying complex numbers when we're doing quadratics? Because sometimes you get quadratic like this, where you can actually solve this for x. I mean, let's try to solve this for x. X squared equals negative 16. We move that number over by subtracting it. And then, of course, you're going to take the square root of both sides. Don't forget plus or minus. We get x equals plus or minus. Let's go ahead and pull this I out. So I times square root of 16. I know I'm going 2 steps. Some of you will go right to 1 step there. Plus or minus 4i would be our answer. Just want to show you and make sure you do that first. Before you do anything, take out that I there. So I might try to factor this first. However, factors 2 that add to 2, I can't think of any. I don't think that's going to factor. So you want to use the quadratic formula. That's our backup plan. So we'll go negative b, negative 2, plus or minus square root of b squared, which is 4 minus 4 times a times c, all over 2 times a. Sometimes I'll kind of figure this off to the side up here. That'll be 4 minus 8, which is negative 4. Okay, so I've got negative 2. I'm going to split this up into 2 fractions, plus or minus square root of negative 4 over 2. Simplify that, you get negative 1 plus or minus, this is really 2i over 2. And hopefully see that you can cancel that. And so you get -1 plus or minus I. Look for a pattern. So you want to be able to look for patterns in these. The I to the first power is just plain old I. I squared we know if memorized is -1. And if you think about I cubed, couldn't we just multiply these two, I times -1, I times I squared is I to the third, so I times -1 is -I. I squared, I to the fourth is really what? I squared times I squared is I to the fourth, so -1 times -1 is 1. Are you seeing a pattern among these four? I hope you do. And so if we go to the next four, it'd be I to the fifth, I to the sixth, I to the seventh, I to the eighth. And what's going to happen here, if you take I to the fourth, multiply by I to the first, 1 times I is I. Take this, multiply by I to the first, I squared is -1. -1 times I is -I. -I times I is, ooh, that's going to be weird, -I squared. What is -I squared? Well, that's -1, which is 1. Do you see the pattern here? I, right? -1, -1, -I, -I, and 1, and 1. You can see this pattern is going to continue. It just keeps on every 4 numbers. It's going to continue. So if you have a number like, and this is some way you can do it by hand here, like I to the 15th power. One way to think through this is how many multiples of 4. If we have a remainder of 1 or 2 or 3 or 4, that's really like a remainder of 0 there. We'll have, we could figure this out. What I mean by remainder is there's groups of 4 here, right? So I'm going to pretend how many groups of 4 can I get out of 15? Well, if I divide by 4, 15 divided by 4, and try to write that as, say, a mixed number, that would be 3. It's not quite 4, is it? 3 3/4. Or old school style. Do you remember this? 15 and 4. We do 15 times 3, which is 12. You get 3 is your remainder. And so this number right here, or this number here, you want to think through, if you think through your remainder, that's going to tell us what the answer is. So if you look at I to the third is -I, so this is going to be -I. So let's think through another one. Oops. Just erase that real quick. So we have I to the, say, 22nd power. Well, let's divide that by 4. 22 divided by 4 is 5, with 2 as my remainder. So 2 is my remainder, so my answer is -1. And so you can just do that over and over again to get really big exponents here and figure out what their actual value is just by knowing that pattern. Complex conjugates, please add these 2 homework problems to your homework. They're about these complex conjugates, and basically what this says is that A plus BI is the complex conjugate is A minus BI, that they will always come in pairs. So if you have something of this form, well, there's going to be a partner there. You're going to have 2 roots that are together here, or vice versa. And the conjugate idea is this. If we multiply by the conjugate, see, it's not okay to have I in the denominator. And so we can actually get I out of the denominator by multiplying by the conjugate. So 3 minus 2i instead of 3 plus 2i. So I'm going to multiply by 3 minus 2i. And up top you get 6 minus 4i, if you want to write it that way. Down here you've got first times first is 9. Now inside, outside cancel. So I only have to do first and last here. So I'd say minus 4i squared. I don't know if you're catching on to